Hey guys, Alan here. Welcome back to the workshop. It's been a while since I posted a video. It's not for the want of trying. I've certainly been spending time in the workshop. After I posted the last video showing the compressor working, I did actually spend some time trying to do something with the petrol engine, and I did get it mounted, but I was still missing bits, and after wasting several days I just gave it away. I have to wait until the bits turn up. So in this video I've turned my attention to a project that Matty did from Matty's workshop, and you'll see a link below, where he made an oil scavenging device. It's basically a rubber belt that rotates through oil contaminated water. Belt picks up the oil and scrapes it off, and tramp oil, as it's called, is a big issue for me in my milling machine. So I thought, well, here's all the inspiration I need, and starting from his basic design, Matty's basic design, I've come up with something of my own. Now, I was all over the place with this, and I needed to experiment with various bits and pieces, how to put a pulley on a windscreen wiper motor, for example, and various other bits and pieces. So this video is a little bit disjointed, I'm afraid, as I work through the various bits and pieces. But let's get into it and see how it worked out. So I sourced a used windscreen wiper motor, and the actuating arm was attached via a tapered spline onto the output shaft. So I took the arm off, and then I needed to find some way of attaching something to this tapered spline. Right, so I've got a bit of a setup in the lathe here to use the DTI to try to understand what the included angle in the taper is, or what the angle of the taper is. And it's pretty tricky to get this. This is quite a short taper, but I'm thinking that's probably going to be good enough. So that's 9 degrees. I'm going to make a test piece and see how that goes. I'll do a proper trial fit while it's actually in the chuck, but at least we can see we're somewhere near it. So I think we'll part that off and try it out. Let's take it over to the bench and try it out properly. Okay, well, let's see how well that turned out. I reckon that's pretty good. It's not all sweetness and light though. So I've pushed this on and held it in place by doing the nut up. So now I think I need a puller to get it off. But so obviously the tapers are a reasonable sort of match. But I bored it out slightly oversized, so it's actually gone down below the end of the shaft there, which isn't ideal. So as a test piece, that's fine. At least it proves that I have the taper angle correct. But I did go in a bit deep. Alright, let's see how we get it off. Okay, see if we can see a witness mark where it was binding. Okay, well, it looks like it was, I don't know whether you'll be able to see that, but it looks like it was only contacting right at the top edge. So it looks like the angle could certainly be improved. Okay, so just to explain this setup, this double pulley came from my AR5 tool and cutter grinder. This half was the one that was doing all the work, and the pulley is completely worn out. You might be able to see that the belt was pretty much running in the bottom of the groove. So my plan is to machine that off. This part of the thing has had no use at all. So my plan is to machine this off and create a new hub on this side of that and make it into a single pulley. Now I've got it sitting on an expanding arbor. It's an 18mm bore, and so it's sitting on that, and I'll probably have to create a plug and then re-bore it for the size that I need, and it gets driven by this drive dog here. So let's see how we go. So I'm going to start by truing up the centre. So that should have that running nice and concentric now. Alright, so checking the run out after the truing up the centre. We're within, what's that, 0.02 of a millimetre. And that's certainly going to be good enough for what I'm trying to do. Probably could have got it better than that, but anyway, that'll do. Well, if you couldn't see how badly worn it was before, you certainly can now. Okay, so that's got us down to the original, this pulley size. Now I've got to keep going down to make the, oh, there's a grub screw still in there. Is there? No, there's no screw there. Right. So I've got to machine the back side of this side of the pulley. Right, it's time to start thinking about what diameter I want this boss to be. I was bloody careless. I brought the carriage back so far I bumped it out of the holder. God, there's so many things you can get wrong. Alright, well, I think we managed to survive that experience. Well, hopefully so, anyway. Not getting a very good surface finish there, and I think it's because we're getting all this stuff built up on the end of the tool. Alright, I'll just knock that the corners off. There's a bit of bruising there which I'm not happy about. I'll clean that up with a file, I think. Alright, so ready to take this off now and look at how to mount it on that windscrew wiper motor. Right, so I've got the pulley back in the lathe, and I'm turning a recess in the back of it here to take this bush that I made earlier, and yeah, so doing fairly light cuts to open that out. Okay, so I decided to take another spring pass, so let's see what we got. So I was originally shooting for 21.08. I don't know whether you can read that anyway. I was originally shooting for 21.08. And I got 21.078. I'll take, I don't know whether you can see that, I'll take that anyway. Bit of luck getting that close. But that gives me the 0.02 of an inch shrink fit, which is, I don't have much experience with this stuff, but I gather, believe, hope, 0.02 of an inch shrink fit or press fit should give me a pretty good grip on that thing. Right, so I think I'll run the, I don't know, there's still a bit of a sham for this, so I think we'll call that done and see, have a go at pressing the piece in and hope for the best. So I've got some things I use as press blocks here, and as luck would have it, that's a rather spectacular fit in the top of that. This will look at the slight chamfer I've got at the top, around the top, so hopefully that'll be alright. Use a socket, a universal sort of a pushing and shoving thing. Alright, looks vaguely level. Let's give it a bit of a push and see what happens. It looks like it started alright. I'm not seeing any pressure going up on the machine. Yeah, that's going in a charm. Yep, that's going in a charm. And that's it, it's bottomed out. So, hopefully that will now fit on that tapered spline on the end of the windscreen wiper motor. Let's go and have a look. Okay, so I've put the pulley on the output shaft of this motor, and let's see what it looks like. I'm not holding it dead still, but there is a little bit of run out there. Try and hold it so it's hard to see. There's a very small amount of run out, but I'm happy with that. That's certainly quite adequate for a low-speed V-belt drive. Yeah, that'll be just fine. And as was my goal, it's going to make it easy to change the speed of the driven belt, the oil collecting belt, I mean. I could lop most of this off, but it's not doing any harm, and I might, I don't know how well the whole project will work out. If it works out great, fine, but otherwise I'll leave this on here. It means I might be able to use the pulley for something else. Now for the other part of the deal, I'm going to use this pulley. This is the first one I made when I was trying to get the AR5 going, and I messed it up. And as you can see, I've got a different thickness here, but it obviously doesn't interfere with the performance of the thing as a pulley. So I'm going to, and it is about twice the size of that one, so that will give me a 2-for-1 speed reduction, which I think would be pretty good. So now it's time to do battle with the wheelbarrow wheel and get the inner tube out and see how wide a belt I can cut from it, because that will determine the size of the rollers that I need to make. Okay, so I want to use the inner tube from this wheel to make my belt. So I thought I'd just, it's just sitting on an axle poked in the lathe chuck, but I thought it would be as good a place as any, as good as way as any to hold it. So let's see how we get on. Now what? Not nobody's tyre fitter, that's for sure. Oops. I'll get in there. Right. Right, I think we're off now. I hope we are. And get the rest of it out. Oh, there we go. Oops. Right. Okay. Not that far. Let me get the tube out. Oh, probably should let the air out of the tube first, shouldn't I? It's a rookie error. I was just assuming it was flat. Let's see how we get on. I might go over to the bench. So I cut a band out of the inner tube from the that wheelbarrow wheel, and as you can see, perhaps you can see, it doesn't want to in its natural state. It's got a good old curve on it, and it's not dead keen on staying flat. So to get it flat, it needs a bit of tension, which is fine. But that's also a reason why I decided that I needed to have two rollers where each roller was supported at both ends, so I could get that tension on. And that's the other advantage of the belt drive. I'll have the pulley on the end of one of the rollers, and it's not putting any tension on or loading on this shaft, which wouldn't be designed for that. Right, so this guy is about 100 wide. I'm going to make my rollers out of a round tube. This nice rusty piece should have a bit of friction on the outside surface of it. And I have these bearings. Not sure what I stole them from. They were retired from something, but they're good enough for this job. And they're nice, going to be a nice press fit in the ends of the tube. So that takes care of that. And now I've just got to make a shaft up, which will be the right size for that. And this pulley can go onto. Right, so I'm making the first shaft out of a bit of 5/8 of an inch round bar, and you can see I've already done the land for the bearing, which is a 15mm diameter, and I'm getting started on an M14 2mm pitch thread for a retaining nut. So I think this will probably be the final cut. Right, let's give that a try. Much prefer these things when they're right on the close limits. I just think that feels better to me when they're like that. Okay, so I'm making the rollers. Now when a flat belt runs on something like this, it's a good idea apparently to have a slight doming on it to help the belt centre on the thing. And I looked at my belt sander, I could see that was the case, and I scaled off that and figured I needed about 1/2 millimetre to be 1/2 millimetre high in the middle. So I've done this one using a setup that seemed to work, so I'll show you how that was. So I've got a sacrificial ring here so that I can go right up to the jaws or right to the end of the thing. My standard chuck key is too short for this, so use this bit of a lash up. Right, and it needs a bit of support. Get the tool post set up. So to get this, what I did essentially was divide this into three and do it's basically 3/4 of a degree angle on the top slide, and I achieved the 3/4 of a degree using a pair of angle blocks. I don't think you'll be able to read the angle setting on them, but maybe you can. Anyway, so these two together add up to 3/4. It's going to be a case of near enough is good enough. I set them on the back of the top slide mounting and eye it off against the end of the top slide. As it's currently set, it's right for doing this end, but I'm going to put my marks on first. That's marked one, and the other one. So I just cleaned the face of this middle section off a little bit. Yeah, that'll be good enough. So now, as I said, I'm set up for doing this, so we'll come back here now and set this, leave this actually set on the 0, and then wind the top slide in to put the taper on. Okay, I think I'll do for that end. So now I've got to turn my 3/4 inch angle block around so I can go up this end. Still got a bit of a step there, but I think we'll leave that alone and do the rest of the file. Right, I mean, I'm sure it's going to be somewhere near what we want. Don't think there's room for me to film while I'm filing. Oh, we'll try over here. The thing I've got to watch out for when I'm filing is these jaws whizzing around. So I'm using a lathe file for this. It has single cut teeth with quite a rake. Now I have to go and clean the file. Yeah, so this seemed to rake quite a bit of material off, so I'll do it once more and then we'll have a go with the emery paper. I'm thinking that's going to be good enough, so I'll have a look at it with a straight edge. Yeah, I think that'll be fine. Right, it's both of them done. Okay, so this is going to be an upright or sort of a structural column, and I'm going to drill a hole in the bottom here for the lower roller. Now the roller shank is actually 14mm, so I've got a choice. I can use a 14mm drill, but I think considering the material here is relatively thin in relation to the size of the hole, I think I'm going to use a step drill instead. If I can find where I put the damn thing. So I changed my mind. I've realised, of course, I've got to go through both sides, so I've got no choice. I have to use the twist drill. Still like using step drills when I can, but in this case we better drop this down a bit. In this case, because I've got to go through both thicknesses, it's better to use the twist drill. Okay, it's raining again. Alright, so let's check that out. Okay, well that's a start. Now I've got to make a companion piece that'll sit on this side and support the outer ends of both of the rollers so that they can withstand the belt tension when it goes on. Okay, so moving on to the upper roller. Need a clearance hole here for a 15mm shaft, so I'm actually going 5/8 drill. Some of these holes that I'm drilling are bigger than I would normally choose, but I'm governed by the size of the shafts that I've got in the scrap bin, or the size of the material I've got in the scrap bin to make shafts out of. Now for the bottom roller, the roller rotated on the shaft. For this upper one, the shaft and its axle will be fixed because I've got a pulley on the end of it and rotate that from the outside using the motor. So I've got these little bearings. I'm not sure what they're left over from. I think I bought them for something. Well, I did buy them for something, but I can't remember what now. Didn't use them. Anyway, perhaps not the ideal choice for this, but I've got them, so I'm using them. So they get secured by 6mm bolts at 53 centres. So I've got, I don't know whether I've got enough room here for that bolt, that drill. Well, we'll find out. Now when I bolt this on, I have to use countersunk head screws because I can't have anything sticking out on the roller side. So since I've got it set up here, I might as well do the countersinking from this side. So at this point it doesn't matter which side gets done. Bring the quill DRO into place, so once I've worked out how deep to do this one, I can do the other one the same. Alright, I think that'll do. So we've got to go in 3mm. Right, that's my 3. Yep, that's good. Okay. Not sure what I'm going to do next. We'll see. Okay, so my rollers were made out of some bits of water pipe, so I've got to clean the ends out and then make some caps that I can drill to put holes for the axle. The exact size here doesn't matter because I'll just make the caps to fit. This piece of bar stock here, I don't know what that came from, but should be able to get some end caps out of that. So I think that's cleaned up well enough all around. It's actually cleaned up surprisingly quickly. Didn't have to take much out at all. I've gone in 5 because I'm thinking to make the end caps 3. But it might actually be easier to press them in if they're a bit thicker than that. So perhaps I'll make the end caps 5 and put this in at 6. So we're going a bit further. So we'll call that one done. So we'll turn it around, do the other end. See if I can get it roughly the same size. Might make it easier to turn the end caps, but again, not critical. Yep. Alright, we'll measure them up and get started on making the end plugs. So I think we'll start by putting a hole in there that's slightly smaller than the shaft diameter, and I'll be able to bore that out to be the fit that I want, which is basically a loose sliding fit. Alright, that should be deep enough. Anyway, let's knock off this disc on the end because I don't need that. and face it off. Right, I think I'll bore it to size when I've got the discs actually in the roller. Concentricity isn't a big consideration here because it's such a slow turning thing, turning rubber belt, but it's probably still a better way to go. So let me get set up to turn these down to size. That's a pretty good surface finish. Because what I'm looking for is a press fit into the end here. Yeah, I think we'll get that. That's almost started, so that's fine. Right. So I need to cut a 5mm disc off. Get set up with the parting tool again. Well, that's a first. The remainder from the parting operation actually came off both sides at the same time and finished up on there. Oh, that's a win. Yeah, so that one didn't come off quite as nicely, but that's all right. Okay, well, let's see if we can get these end plugs pressed in. And recessed slightly. Suppose I can do it this way around and see what I'm doing, can't I? Actually, I think I'll leave the recessing for a moment. Yeah, I might leave the recessing for a moment. I'll come back to that. I'll leave myself a bit of scope for messing about if I have to. And the other one. So I've got both ends set up now. Just have to put it back in the lathe, bore them out for the axle. Okay, so I think I'm making some progress finally. Got the bones of this thing sorted, so that roller's done. This one here is the one that has the bushes in at each end, and whilst the bushes are pressed tightly into the roller, at the moment it's free to turn on the axle. So I've got to do a bit of a probably some tack welding. It won't take much because there really isn't much force to be transmitted. These bearings have a small amount of I don't know what you call it, alignment capability anyway, so I haven't got them quite right yet. You can see it just it's not completely happy to turn over, but it certainly seems to work. When I made this, it's another mistake. Something went wrong, and that finished. That's supposed to be where the pulley goes, but it went undersized. But fortunately, there was enough material that I could turn it on for this end. So I've got a really good fit there now, and the belt actually tracks very well already. Surprisingly so, actually. No, the pulley's turning on the shaft now. So I'm quite happy with that. But what I had in mind for the design anyway was, if necessary, putting a joint in on this side, which would allow me to adjust the spacing of the axles. In fact, thinking about that, I should have put this spacer bar lower down so there was room for the... anyway, so a lot of progress, but still there's a lot to do. I've got to work out a base for it. I've got to cut this off because I want this whole lot to fit inside the column of my milling machine. So I'm going to cut that off and then work out how to fit mount the motor somehow. Maybe even like that because of the length of it. But this is a Z section belt. It's pretty much the smallest one I could easily get my hands on. Yeah, so looks like that might be the go. Something like that, with some adjustment for belt tension. And I have to make it so that the motor section here bolts onto the lower section. Otherwise I won't be able to get it through the hole in the side of the milling machine. Anyway, I'm stopping here for now because I've already gone on for longer than I wanted to for this, mostly because there was a lot more effort in this than I thought there would be, in part because of mistakes in correcting them, but there was just actually quite a bit of work. So whilst I've made a lot of progress, there's still a lot left to do. So I'm going to end this video here. Hope you enjoyed it. Thanks for watching anyway, and hopefully you'll join me on the next one where I'll finish it. Cheers.